Welcome to Learn Extra. Today, Grade 12s, we are going to concentrate on our statistics. And in particular, we're going to focus on comparing symmetric and skewed data. And then we're going to look at use of a statistical summary, scatter plots, regression, correlation to analyze and make meaningful comment on given bivariate data. Now that all sounds very intricate at the moment, but you'll see once we start working on the questions, it's not so bad. So let's recap a little bit at the moment and remind ourselves of some basics we need. And the first one is the 5-number summary. The 5-number summary uses the following measures of dispersion. Now, I want you to think about dispersion. I think it's quite an easy word to engage with. They talk about the minimum, that is the smallest value in the data. So if I gave you a string of numbers, we look for the smallest one, and that would be the minimum. Then we have the lower quartile, and the lower quartile we use the symbol Q1 for. The median of the lower half of the value, so that means halfway on the lower half. So if we go for the median, which is the next one, which is known as Q2 as well, the value that divides the halves into halves, and we'll talk about that now, and the upper quartile, which is known as Q3. And last but not least is the maximum value, the largest value in the data. So let's just talk about that quickly. So I've got 4, 5, 6. I'm just going to use some random data here. 7, 8, 9, 10. That should be fine. Now, if I'm looking at this, would be the minimum. This would be the maximum. The next thing I would do would be going for the median, which is the middlemost piece of data. So that's the Q2 or the median. And then to get the Q1, I would look for the halfway on the rest of the data. So in this case, it would be your 5. And over here, it would be your 9 for your Q3. And then you would put your data out on a box and whisker plot, or even just list it like we can do now. So let's go on and see what else it says. It says, write the box and whisker plot. A box and whisker plot is a graphical representation of the 5-number summary. So let's have a look at what that looks like. Over here, you can see the box. This would be your minimum value. This is your lower quartile or your Q1, your median or your Q2, your upper quartile or your Q3, and of course your maximum value. Now, why this box and whisker is quite important is it also gives you an idea around skewness. At the moment, the way that is drawn, it's nicely balanced. If you look at it, the whiskers are sort of the same length on either side. And your Q1 and Q2, the median is not that far off. It's a bit closer to Q3 than it is to Q1, but it's not that bad. So that gives you an idea of the skewness, but we'll talk some more about that in a while. Right, and then we have what we call the scatter plots, and that is lines or curves of best fit. Now, of course, if you do any of your other subjects, like your biologies or life sciences, as they call it, or your geography, that's where you would hit these things as part of the normal work there. But of course, in mathematics, we do it as well. So that would be plotting data on a scatter plot diagram that shows a trend in the data. Data would follow either a linear, a quadratic, or an exponential trend. To be honest, we're probably going to concentrate on linear more than anything else, but they could give you data and say, what does this look like, or get you to plot it and say, what does the line of best fit look like for this, or the graph of best fit. So the linear one, there's an example of how the data would look, and you might even have an outlier here or here, but basically it's a linear description. Or you can have something that goes up and goes down, like a quadratic, there it is, or you can have something exponential on your data. And exponentials, in actual fact, are very real. If we look at something like population growth or something like that, it more than likely would be exponential more than anything else. Anyhow, there's your 3 kinds that we mentioned, but of course there are many others as well. Right, let's go to our first example. The ogive below represents the feedback from 132 pupils. Now that's important to remember, on how many minutes per day they spend on Facebook. And it's quite an interesting graph if we look at it. I'm just to try and get it in position that you can actually look at it properly. Now remember, an ogive is like an S-shaped kind of curve. And what we do there is we use the cumulative frequency to get to it. Now you'll see we're going to have to do the cumulative frequency, which is an interesting exercise. Use the ogive to sketch a histogram of the data. Now, please remember there's a difference between a histogram and a bar graph. Histograms are joined together, so we need to go back and sort of get a kind of table going. So let's have a look at how we're going to do that. Now, what I'm going to do is I'm going to put a little table alongside here. I don't think I'll win a prize for nice drawing here, but I'm sure it'll do. And over here, I'm going to have the interval, if you like. So, since they seem to be showing me every 5 minutes, let's go 0 to 5, 5 to 10, 10 to 15, and 15 to 20, and 20 to 25, and 25 to 30. And I think that's as far as we need to go. Now we just got to be careful because these are the cumulative frequencies. So obviously the first 5 minutes, there are 8 people. And that's easy enough to do. Now in the next 5 minutes, those 8 have got to be taken away from those 18 to tell me that there are actually only 10 people in that division. Now in this one we've got 33 in total at 15 minutes, but we must take away the 18 that are in the 0 to 5 and the 5 to 10. So if we do that, we are going to get 15, I think it is. Yeah, it is 15. And then here, to get from 15 to 20, we must take 33 away from 63, so it's 30. And then carrying this on, I need to just access the top of the graph. We take our 63 from 99, and if we take 63 from 99, we also get 36, I think it is, yep. And then the last little division, which I still need that top number for, we're 99 to 132, which is going to be 33. So what I've done is undone the cumulative frequency, which is what we would use for the ogive. And now we are ready to work with our histogram, because with this now we can draw our histogram. Right, so let's get ourselves a histogram going. So I think I need some straight lines, so let's use one of these and one of those. And what I need, I think that might be the purple or something, but it doesn't, it'll do fine. I need to go to 30 versus 36. Okay, so 5, 10, 15, 20, 25, 30, 35, and I need to go to 36. So let's take it up in 5s as well. 5, 10, 15, 20, 25, 30, 35. That's good enough. So on this axis here, we would have frequency. And over here, we'd have intervals. Let's have a look at it. And we're going to now do this thing. So if we know from 0 to 5 is 8. So we would go across and we would go to where 8 is. And again, this is pretty much a freehand sketch for now. So there it would be, 0 to 5. And I'll just write the values in. So that's 5, that's 0, and that is actually 8. And then the next little thing of it will be up to 10. So we would go to 10, start over there, and we would draw it down. Okay, and so we would mark that 10, let's just put them all in, 15, 20, 25, 30, 35. Of course, you will be doing a nice little masterpiece here, not like my attempt at a very scraggly looking graph. And 15 for the next division. So I take my thing over here. 15 would be over here. There's 15. The next one would be 30. So again, up to 30. So let me just mark that in. So we've got some numbers to help us here. 10. That would be 20. That would be 30. So I want to take it up to 30, across and down, and then I think the next one was 36 and 33. Yes, it was 36 and 33. So I would go along to it here, Might take it up to 36. Okay, just having some fun with my little line there that doesn't want to stay on its own. Let me just go back to there, 36, and draw it in. This shows you must be careful not to press select by mistake, as you can see. And last but not least, you've got your 33, and that goes down like that. So that would be your histogram representing the amount of time spent on Facebook in terms of frequency. Now, the next question says, determine the median. Now, what we need to do for that is we know that we have 132 pupils. So the median would be the middlemost bit of data, which would be the 66 one. 66. So what I have to do now is I have to go to my graph, and I've got to look for my 66th person on the graph. Okay, which would be over here somewhere. 66. I trace it across to my graph, and then I would read it down. It looks like about here, so it looks like about 21. So in the light of that, I would say the median is 21. Okay, so right, what else do they want to know from me? They now say, determine the estimate mean number of minutes. Now, why estimate? Well, we're working with grouped data, and if we're working with grouped data, it's not so easy to find the actual mean. So what we do is we take our interval and we take the midpoint of the interval. So if I go over here and I look at 0 to 5, the midpoint would be 2, 5. The midpoint over here would be 7, 5. Midpoint here 12, 5. The midpoint over here would be 17, 5. And over here it would be 22, 5. And this one would be 27, 5. But obviously, we must have 8 times that, 10 times that, 15 times that, 30 times that, 36 times that, and 33 times that. Now, of course, you could just go and work that out on a normal calculator. But I know for a fact that the next question asks you about standard deviation, so it makes sense for us to use the calculator and to work with our frequency on. So let's bring the calculator up. I have input all the data. If you have a look there, you can see it all in there. You can see there I started it, I inputted how many of everything I had, so it's ready to go. So once I have done that with the data, I want the mean. So what I would do is I would clear the calculator, and then I would go Shift Stats, and there it shows me what I want. So I want to go for variance, so let's take 4, and over there you can see that number 2 is the mean, and X with a bar is the mean. So if I take 2, and I press my equal sign, it should give me my mean. There it is, 19, 1. So that means my mean is 19, 1. Now that's pretty close to my median, but we'll worry about that later on. Okay, so we've done that, and that's an estimate. And then they want the estimated standard deviation for the data. So we will go back to our calculator again. We would clear it. And then we would hit our Shift button and Stats mode again. We would again go to number 4 for the variance, and now we want the standard deviation, which is number 3. And if we do that, we're going to get 7, 3. If we take it to 1 decimal place, I suppose we could take it more than that. Let's take it as 7,29. Okay, so let's put that away. Actually, no, let's leave it there for now. Let's see what else they want from me. Now it says, determine the interquartile range for the data showing or working. So let's just go back up here. We have the standard deviation at 7 points, I think it was 29, but let's just make sure. Yes, it was. They now want the interquartile range. Now what that is the Q3 minus the Q1. So in other words, what we're doing is we are ignoring the extreme extremes, the bottom extreme and the top extreme, and we're interested in the middle amount of data. Now that can come straight off this particular drawing we've got with the ogive. You don't have to do anything special for that. So what I can do now is I can say, look, 66 was the halfway mark. So the bottom half of the data would be 33. So I would go to 33. I draw across to my graph. And it so works out that it's exactly on 15, which is very good news, because it's always nice when you don't have to guess too much. So we know that this Q1 is 15. That's my Q1. This is my Q2. And now we need a Q3. And remember that there were 66 pieces of data, so we need to go down 33 to get the next bit of data. So 10, 20, 30, 33 would be about here. And then we take it down to the x-axis. And it's decided not to listen to me, so let's just move the graph down a little bit and carry it on going. And it looks to me like 24. Okay, obviously with a nice grid you can do it a little bit more accurately. So we have to take 24 minus 15, which is 9. So the interquartile range is 9. Just for a matter of interest, although it was not asked, what would the range have been? Remember, the range is the smallest amount of data, the difference between the maximum and the minimum amount of data. So that would be a bit different, because then we would be taking into account these top sections, these little bits where there are extremes of people not doing much. Anyhow, let's read on with the question and see what else it says. Okay, so we've got the IQR. Now, by referring to the ogive or the histogram, say whether the data distribution is positively or negatively skewed. Now, if you're looking at the ogive, it's not so easy to see, but if you look at this, it's much easier to see. Can you see that the concentration of people using Facebook is on this end of the spectrum? So it's on this top end here. But it's easy enough to look at that and guess, but there's a nice way we can do it. What we can do is we can use the mean minus the median. Now, do we know that? Yes, we do. We've worked that out already. We know that the mean was 19,1, and the median was 21, if I remember rightly, but let's just make sure. Yes, it was. Now, if I subtract that, I'm going to get a negative answer. In fact, I'm going to get negative 2,9. Now, if it's negative, so it's less than 0, we say it is skewed negatively or to the left. Now, because your concentration of people is on the right-hand side, we're basically saying that's the skewness on the left, because it's not behaving consistently right across. So I think it's easier to tell off the histogram, and certainly it's better to use the little expression mean minus median. Obviously, if you went mean minus median and you've got a positive number, so let's just talk about that because it's worth mentioning. So if we said mean minus median, and we got greater than 0, we could say it is positively skewed or skewed to the right. And what it would mean in terms of my histogram, if I drew my histogram, is that predominantly the people were down here. And then only a little few were over there, sort of story. So most of the information would be on the left side of the histogram. Okay, so that's worth bearing in mind and thinking about it. Let's move to the next question. Right, example 2. The marketing budgets and sales income in millions of rands. Now, I'm not going to work with the millions, although you'll see sometimes in the question they'll write the million out. Other times they'll say 2.5 million. So we must just bear in mind that there's not we must use the same thing for either one. Of several companies we investigated, and the following data was collected. So there's my collection. Company 1 had marketing of 3 and a marketing budget of 3 million and a sales income of 32. And as I said, we're working in millions, so 56 for company 2, 1 to 18 for company 3, etc., etc. Says use a grid to draw a scatter plot for the given data. Now, what we're going to do on our scatter plot is we're going to put our marketing budget over here and our sales over here. And remember, strictly speaking, we should actually give a heading, so we would say the scatter plot representing the marketing budget to sales. Okay, it's always good to give a heading to anything you do in statistics, and in fact the first one I said it, but I didn't write it down, so please make sure you do that. So now we're going to go and plot. So what we're going to do is we're going to plot 3 against 32. So 3 against 32. Okay, hopefully that's a good enough representation of that. The next one we're going to plot 4.5 against 56. 4.5 against 56. The next one we're going to plot 1 against 18. 1 against 18. And then the next one we're going to plot 5 against 48. 5 against 48. Right here somewhere. I think I've got a little bit skew with my 5 there, so let's just move it over a little bit. Oops. I just erased the other one by mistake as well. So let's go back to what was it again? It was 4.5 against 56. 4.5 against 56 and 5 against 48. And then the last two bits, I think 7 against 60. 7 against 60. And last but not least, 2.4 against 25. 2.4 against 25. Right, now if we look at this data, there's not a lot of it, there's a bit of it. You can see that this is more or less forming a straight line. I don't think it would be exponential, I don't think it would be quadratic, certainly not with what the information I've got at the moment. So just my gut feel on this is if I was asked for a line of best fit, it probably would be a straight line. Let's read on. Right, the next question talks about, I'm going to have to go back to the things I think. Well, we've done this one. Determine the equation of the least squares regression line. Now, all we're going to do for that is we're basically going to work on the calculator and we're going to input. Now, this time I haven't input in advance, so I will do it with you, which is good because I think you need to see how it's done. We bring up the calculator, we clear it. First of all, when you're doing stats, you must get your mode to be stats. Okay? Then you want to do the line of best fit, and we decided it is a straight line, so we're going to hit number symbol, what, 2. And there comes our frequency table, which we're going to ignore because in this case there's just one bit of data. So what we're going to do now is we're going to input the 3, and we're going to hit the equal sign to enter it. Then we're going to put 4.5. I hope the point came out. No, it didn't. There it is. And I press the equals. And the next one is 1. And I hit the equals. You must hit the equals to enter. The 5. And I must hit the equals. And then I need the other data. So I'm just going to bring that calculator down for now. It's going to be 7 and 2.4. 7, the equals, and 2.4, and hit the equals. Now I need to go to this column, so I bring it to the top again, because it's best to enter it in the order you were given it, so you don't get confused. Right, now with 3 we had 32, so we're going to put 32 and equal it. Then we're going to go 56 and equals. Then we're going to go 18 and equals. 25. So we're going to hit 60 equals and 25. Now you can see that your data is matching the left and the right side. The frequency there is not a problem, it just hangs there. I personally like to keep my calculator with frequency on because often you're getting group data and you need to work with a frequency. Right, so now we are ready to have a look at the line of best fit, or the linear square root regression line. So what we're going to do now is we are going to clear the calculator. We are going to hit our shift and our 1 to bring that up, and we want our regression, which is number 5. So there you see they give you the list. So number 1, I want the A value, so I hit the equals button and there it is. So the A is equal to 10,49, and then my B value, so I clear it again, I go shift and I hit the stats button and I again hit regression and I want the B value, and that is going to be number 2, and I get the equal sign, and it's 7,69. Assuming I'm taking it to 2 decimal places, they would tell you that. In this case, it hadn't said the question, but they would say 1 decimal place, 2 decimal places, 3 decimal places. Right, so we clear it again because we're going to go back to it at a later stage, and we park our calculator. Let's go back to what we were asking. So we needed this equation, and the equation was y equals a plus bx. If you're confused, you just go back to your calculator, and in your stats mode, or whatever way you want to do it, that and that. Wait, that's not behaving nicely. Let's just go here, stats. You can see there it is a plus bx. So if you forget, you can always look on your calculator key to remind you. Right, so over here we have y equals 10.49 plus 7,69x. Of course, that is just a normal straight line where that's your gradient and that's your y-intercept. Right, the next question says to me, determine the correlation coefficient of the data. Now the good news is that is already done. So if we go back to our calculator, we clear it, and we go shift 1, it comes up there, and I hope I haven't got to enter this data again. I hope I didn't lose it there when I was trying to be clever and showing you the other stuff. It doesn't look like it's behaving. Let's just see data if it's there. No, I have to enter it again. No, I don't. Sorry, it must be somewhere else. Okay, let's just go and have a look. I've obviously put it somewhere I shouldn't have. Stats mode, and it must be under number 2. Yep, I'm going to have to enter it again. Sorry guys, that was a little bit silly of me. So let's go back to that information, and let me enter it again for you. Sorry about that, I mislaid it. I actually threw it away when I was looking at that other aspect for you. So let's go, I'm just going to go quickly on it. 3 equals 4.5 equals 1 equals 5. Oops, I see it didn't work too well for me there. Let's just take it up 1. Okay, delete it. Delete. That's what happens when you rush your information. Okay, it's not been nice to me, so I'll just go back there and I'll go to it. So setup, stats, I want to go for line of best fit, and it's number 2, and there it is. Okay, so I'm just going to enter it again. So if we enter it, it's going to be 3 equals 4.5 equals 1 equals 5 equals, and I need to just look at the screen again to remind me, 7 and 2.4. So it's 7 equals 2.4 equals, and then I go to the other column, up to the top, and now I must input against that, so it's going to be 32 equals 56 equals 18, sorry, too many 8s there, equals 48, to just bring that down to look at the last two, 60 and 25. Sorry about losing that data. It was silly of me because it was done and 25. Come on, 5 equals. All right, so we cleared the calculator. We then go shift stat, and I want the regression details. That's 5. And this time I want the R, or the correlation coefficient, which is 3. And I press the equal sign, and it's 0,946. So R is 0,946. Okay, let's park that. So let's go back to the correlation coefficient. So it says determine the correlation coefficient, so R is equal to 0,946. Now, before we even look at the next question, I'm pretty sure that the thing they're going to do now is they're going to ask you, how good is our line, our linear square line? Is it actually going to predict well or not? You see how he looks at the correlation coefficient and describes the relationship between the marketing budget and the sales income as a strong positive relationship, explained with reference to the correlation coefficient. So remember, it was R equals 0,946. And yes, that is a very good relationship, because if it was perfect, R would equal 1. That would be a perfect correlation. So if that's the case, we're looking at 0,946. That is pretty close to perfect. So perhaps if we were looking at our line we put in, there might be a few points that aren't quite there, but it would look sort of like that. Now the weaker, that would be sort of a 0,946. The weaker my R value is, so if R is equal to 0,5, then what we would find happening is our data would probably lie a little bit like this, all over the place. And as soon as we got to R equals 0,1, well then there would be hardly any correlation at all. We'd have a random looking thing like this, with a straight line in there somewhere, and it doesn't really predict what most of the data is doing. So that is why he's saying it's a positive reference. So you can say, if you're explaining this to an examiner, you can say if R is equal to 1, then there's a perfect correlation. But 0,946 is very close to 1. And so in actual fact, the data is very close to my line that I've drawn, or the line I found. Right, let's see what the next question asks. Given the relationship above, what sales income would you predict for a company that has a marketing budget of $3.5 million? Now remember what I said to you. What this does, which is a bit off-putting, is sometimes they write the thing in full, or sometimes they do it like this. Now when we found our equation, we worked with it like that, 3.5 million. So we're just going to change it to that. We're going to go to our equation, which is up here somewhere. Y is 10,49. And then the other one was 7,69. Now, if they're telling me this is my budget, they're giving me my X value. So all I would have to do is I'd say Y is equal to 10,49 plus 7,69 times 3.5, because remember that's how we've been working with our numbers. So bringing up our calculator, let's clear it. We can go 10.49. Don't know why I'm not pressing that squarely on the thing. Plus 7.69. I've left the point off, so let's just go back and put the point in. 0.69 times 3.5. Okay, and I'm going to get 37,405. So it's 37,4. So let's go back up to the information we had in the beginning. 37,4. And they told me that we had invested 3.5 million. Now, how do I make sure that that makes sense to me? Well, if I look at this drawing here, here's 3. And 3 is giving me a sales income of 32. Here I have 4.5 and a sales income of 56. So it makes perfect sense to me that 3.5 million, it would be more than this, and 37.4 is more, and it's not significantly more because it's not near that. So I would think that is a great answer, and I'd be quite happy with my equation I'd found. By the way, before we even move off it, I want to go back to the line of best fit. If we had plotted in here, on our data we had plotted, over here it would be 10 point whatever, say it looked like that, I don't know what it would look like. When they asked me to use 3.5 is over here. If I've gone to the graph, traced it up and read it off, that would be fine. But this would be what we call interpolation. In other words, what I'm doing is I'm using the equation to predict within the other data what is happening. However, if I said to you a budget of 10.5 million, now I only had data up to 7, so 10.5 is out here somewhere, that would be extrapolation. Because now I have to go outside the known data and use my line to predict. And it's not as good when you get to extrapolation than you do with interpolation. Interpolation is within your data. That's why I could look at that drawing that we had just now, and I looked at our information, and I decided I was happy with my answer of 3.5 million, giving me 37.4. Right, now at this stage I think we're going to go to a break, and after that we will come back and do some more questions. See you later. Welcome back. I hope you had a good break. I want to now talk about question 3, and of course this is one that is close to every teacher's heart, is when they look at how their children are doing in their subject versus another subject. This one says the English and Maths marks for 9 students, so it's not a very big group, are given below as pairs of marks. So you'll see this is pupil number 1. They got 57 for English but 25 for Maths. Then pupil number 2 got 40 for English but 50 for Maths, and so on and so forth. Let's see what the question asks. They say comment on the skewness of Maths and English marks respectively. Well, that means we have to go and look at what we're looking at. So let's have a look if we can get our median and our mean. If we got those two things, we've got that way to tell whether it's skewed or not. So let's start with English. And the first thing I'm going to do is I'm going to order my English marks from smallest to biggest. So 40 is my smallest, 57 is sort of in the middle there, 63 over there, 64 over here, 68 over here, 69 first, then, 74, then 78, and last but not least, 89. So I haven't done a too good job of putting my 40 in the right spot, so let's just move it over there. Now, to get our median, we have 9 bits of data. So if we take 4 away this side and 4 away this side, this would be the median. So the median for my English marks is 68. Now we don't have to do anything glamorous to get the actual mean. We can just do it normally by just adding up and dividing by 9. I just want to bring it down so I can actually look at the numbers without having to move a calculator. Oh, almost. I didn't quite get it right. So let's have a look. Let's clear it. You can change back to normal mode, but since we're working with stats, I'm going to leave it there. It's 57 plus 40 plus 63. Oh, sorry, that was me making a mistake there. 63, I must just press the buttons carefully, plus 64 plus 68 plus 74 plus 69. And now I need to just take the calculator out for now so I can look at the last two numbers. 78 and 89. 78 and 89. Right, that gives me 602, but there are 9 bits of data, so I need to divide by 9 to find the mean. And I find the mean to be 66,888. So that's good enough. And now remember what we do now is we take mean minus the median? Or is it the median minus the mean? I've gone blank now for 2 seconds. Let's just take it back. Wait. No, I think it's the... let me just go back to the first example and just check what it was. I've gone blank and not remembering it. Okay, I think it was over here. I did it. The summary for you. Right, mean minus median. Amazing how quickly one can forget the most important things. Right, so it's the mean minus the median, which in this case would be a mean of 66. Let's make it 0.9, subtract 68, which means it would be less than 0. So that's going to be a negative skewness or skewed to the left. So the English is skewed left. Right, now we repeat the process for our maths and see what they're doing. And we are going to first of all organize our data from smallest to biggest. Let's get hold of a different color pen so we can tell the difference. Okay, 25 I think is the lowest mark, I hope, for the poor teacher's sake, if not for the pupils. 50, 68, 68, 70, 75, 84, 90, and 95. Again, there are 9 bits of information, so for this side, for that side, means that 70 is my median. Equals 70. Now we need to get our mean, so we bring back our calculator, and this time I'll try to be clever so we don't have to move it. It's going to be 25 plus 50 plus 68 plus 68 plus 70 plus 75 plus 84 plus 90 plus 95. And that gives you 625, which we have to divide by 9 to get the mean. And our mean is 69.4. Okay, let's take the calculator down. And now we know we must take the mean, subtract the median, which once again will give me a negative number. And so again it's skewed negatively or to the left. So both of them have the same skewness, which is interesting. It's interesting that perhaps here it's a much smaller amount. It's negative 0.6. There it's a little bit higher. But anyhow, that's fine. They just asked us to comment on the skewness of the 2 marks respectively. Now it says determine a regression line for y in terms of x. So this is back to the calculator again. I can see by now you're realizing that it's actually quite calculator intensive. Okay, we are in stats mode, I think, as far as I can remember, yes. And what we have to do now is we have to get the regression line. So we want to find regression, which is number 5. Okay, it does help if one puts the data in first, of course. So let's just clear that and go back to the data. So let's go mode 2, and let's go to the data first of all, which is 2. There you go. Right, so we're going to put in the data, and we're going to again put them in order. So it is 57 equals 40 equals 63 equals 64 equals 68 equals 74 equals 69 equals, and we need to just park the calculator for a sec, 78 and 89. 78 and 89. Right, now we go to the other column, to the top again, and we again do our things. So number 1 is 25 equals Right, so all the data's in. Now, they asked me for the line of best fit, so we're going to now go and we're going to say, right, let's clear our data. Let's go to Shift, Stats mode. We want the regression. And we want to find all these little bits and pieces. So I'm going to find A, firstly. And so A is equal to minus 11,7. My B, so all clear, back to the data, regression, and B number 2 equals 1.2. And then the R, because I'm sure we're going to need that too, so we clear it. Shift the stats mode, regression, and we get the R value, which is number 3, equals, and that's going to be 0,778. And I think that's good enough for us. We might just have to move that down to what the question was again. Let's just get that calculator to go away. Right, here we go. Let's go to the bottom, to the actual question. We're going to have to maybe determine a regression line, so y is equal to a plus bx. So y is equal to a, which is minus 11,7, and b is 1,2, I hope it was, x. Okay, I think I better just check that in case I wrote it down. Let's just check that one again. I want to just check the b value again. So all clear, Shift stats, number 5, and I want the b value just to make sure I did write it down correctly. 1.2, no, that was correct. Let's trust my writing, obviously. So there we have the equation, the regression line, and it says comment on the correlation between the English and the maths marks. So the correlation coefficient was R equals 0,778, and that's not a bad correlation. It's not perfect. Remember, we were discussing earlier on what that means. It means that basically the line is right, but there's a few bits of data that are not lying exactly on the line. So in terms of my line, if I had drawn it so over here, there would probably be a little bit of dispersion away from it, but not too hectic. It's still pretty strong, so we can say it's a strong correlation. Right, now it says a student not included in this class gained 95% in the English exam, but did not write the maths exam. Estimate the maths mark and comment on the reliability of the estimate. So we're saying, okay, let's go back to the data. This child wrote and got 95 for English. The question is, what do we think she would have got, or he would have got, for maths had it been written? And then they want to comment on reliability. Now, if we look at 95, I think you can see it's beyond our data here. So if we look over here, the smallest one was 40, the largest one was 89, and 95 is firmly above 89. So remember when I talked to you about interpolation, extrapolation? It's definitely extrapolation because it's outside of the data I knew. I don't know anyone else in the class who got 95% for English. So that means it's not that reliable. Hopefully will give us an idea, but we're not really sure. So we go back to this equation and we say, right, well, y will equal minus 11,5 plus 1,2 times 95, which is equal to, bring up our calculator, let's clear it, it's minus 11.7 added to 1.2 times 95. And the answer I'm going to get is 102. So now we can see that yes, it's dangerous. But remember what I said to you, when you do that, it's actually not guaranteed that it'll work there. How can you get 102%? Well, unless they've given you bonus marks or something, it's not possible. So in actual fact, 102% is unlikely. So what we're saying is the child would probably have got 100% for maths. But it's not reliable because, as I say, it's outside of the thing. Maybe 95, you would have got 99 in maths, but it's not behaving on our regression line. So right, so we can say it's not a very good indication, and of course the correlation coefficient tells me that there's room for error, but we can say that they probably would have got 100%, but it's not probably 100%, but not reliable. Not reliable as we must extrapolate as it is outside our data. That would make your examiner very, very happy. Our given data. They would think, whoa, this pupil really knows what's going on. They would be impressed. Right, let's look at the next question. The next question says, a beauty cream manufacturer placed the following advertisement in the local press. And I love these ads. I always enjoy having a good giggle at them, and I shouldn't actually knock any of them here, but I want you to be very critical when you read ads, because in actual fact they are designed to make you buy the thing. And of course with statistics you can be pretty vague about a lot of things, as you'll see. It says 9 out of every 10 women, so that's my first flag, every, were delighted with the new anti-aging cream. So it's an anti-aging cream. Forever Young, shouldn't you be trying it too? So it looks quite good, the woman looks quite good, but really I'm worrying because it said every 10 women. It worries me that. And then it says at the very bottom here, it's a disclaimer. They say, study conducted amongst 30 women over a period of 3 months. Do you think 30 women is every woman? Hopefully you're saying not a chance. I mean, you can't. I mean, imagine I was standing outside the school hall, and the first 30 people that walked out I asked a question about, and from there I concluded that the whole school is doing whatever. You could know that that's not fair. It's not a good indication. So let's see what the questions are. The first question says, if this claim were true, how many women in a sample size of 500 should be happy with the product? Well, they say 9 in 10. So how many 10s are there in 500? Well, 500 divided by 10 is 50. In other words, we are talking about 9 times 50 women, or 450 women. Now, that's a huge leap from what we were told. We were told 30 women interviewed. And now suddenly I'm saying, well, if there are 500, that means that 450 must be thinking this anti-aging cream is fabulous, in which case we better all rush out and buy it because it's going to help us stay young longer. But I don't think that's so. Right, let's see what the next question says. It says, give 2 reasons why the research undertaken by the manufacturer should not be considered valid. Now, what's nice about this kind of question is you can answer just about anything if you can justify why you answer it. Now, the one thing I've been drawing attention to all the time is how many women were actually interviewed. Okay, there are far too few interviewed. We cannot say every woman. If we only censored 30. Okay, so that's a very good reason we can't do that. What do you think a second one could be? And there actually are lots of them. But my big one is, if I look at this, the picture they've got here is of a fair complexion. So what about darker complexions? Does it work as well in a darker complexion as on a fair complexion? They're not sort of saying. The woman they've got there is middle-aged. Well, who's to say anti-aging is only working in that little portion of time? But who's to say there 30 people were representative of everybody? There's nothing that tells us that. So we don't know whether these women were like a spectrum of ages, and maybe we needed to look at them in the 30 to 40 range, the 40 to 50 range, etc. We needed to look at different ethnic groups, because maybe it only works for white skin, who knows, I don't know. But there's no real data, so there are lots of reasons you could give the second reason for. The second reason, I would say, we do not know what woman? Were asked, i.e. complexion, age, ethnicity, and you can name others. And as I said to you, if you can find any other reason that you can justify, they will accept it. Also, the claim of every is another that's very misleading. You can't say 9 out of every 10. They could say 9 out of 10 women censored or asked said they had help with their aging. That would be better than saying 9 out of every 10. So that's another good reason. The advertising company has used the word every in its advert. Why is this misleading, particularly in the South African context? Well, I've sort of answered that already, and we'll just talk to it again. Well, in the South African context, we need to know, as I say, your complexion, your age, your ethnicity. Every, as I say, implies every. It's not every woman, it's a little group of 30 that they've asked. Who knows whether they found those people? Maybe they stood outside Virgin Active, first 30 ladies out, they handed the Queen to them, said, come back in a week and tell us how it's going. Or whatever it is, you don't know anything about the methods used for that research. So every is a big problem, especially in the South African context where we are multicultural and certainly not the same, like, how can I say, singular kind of thing. And no country is actually, if you really think about it. So it's really not a good use of the word. But a clever use of the word, because if you're not a discerning critic of the word, you could think to yourself, okay, maybe I should try this. And it might be completely false advertising. All right, let's look at the next one. Consider the following pie chart. It says people injured while driving a vehicle is what the chart is about. And it tells me that the sober drivers were the grey ones. So I'm going to highlight it in pink, just so you can see what I'm talking about. So they're saying these guys were sober. And then they are saying these ones have been drinking. Okay, now it goes on and it says, what is inferred by the pie chart? Well, I'm sure you're all looking and thinking, well, it seems like you have more accidents when you're sober than when you are not. So maybe it's better drinking than driving, which is a ridiculous assumption. So for me, that's what it's saying to me. It's more so that people had accidents. Okay, so let's see what the next question is. So that's what we need to answer for this. It infers sober people have more accidents. Which, as I say, is just ridiculous. Right, let's look at the next one. It says, what important fact is not mentioned? Well, there's several important facts not mentioned. The first one is we don't know how many people were looked at or where they got these people from. Did they go to an insurance company and say that? And another question is, maybe the people they think are sober are not sober because not everybody was tested. So we don't know how they've got it. So there's a very important fact there. So I would say probably for B, I would say no mention as to how it was collected. Were all drivers tested for alcohol? Because you know that if you had an accident was serious enough, you would go to hospital because you'd be injured, and then they would test your blood and they would know. But if you had an accident and you didn't have any injuries, no one would think to check if you'd been drinking unless you were falling all over the place. But remember, it doesn't take much alcohol to make you, impaired in your driving. And I'm sure you could find a whole lot of other ideas that would help us to get these important facts that are not mentioned. Okay. Right, question 6 says, a teacher draws up the following histogram to represent her class's marks in percentages for the term. beautiful. If I was the teacher, I'd be ecstatic with that because it means I've got a normally distributed group. Normal curve, remember, is that bell curve, and that's what it very much looks like, and I think that was quite nice. However, let's read on. It says, the teacher has created the impression that the results show a normal distribution, which is exactly what my impression was. And then it says, explain fully how this has been done. Well, let's go and have a look at it closely. Well, the amount of people is quite nice because we see that we've got exactly 4 people either side, 8 people either side and 12 people in the middle. But let's have a look at what interval she's used. Over here she's gone 0 to 10. Here she's gone 11 to 40. That is a huge gap of 30 people. Here's only 10 people. Over here, I mean not 10 people, 10%. Over here, 40 to 50 is also 10%. And 50 to 60 is 10%. And 60 to 100 is another 40%. Now you can see that that is already skewing the data because you can't look at something that hasn't been laid out properly. So if you're going to look at this properly, perhaps you needed to take every 10%. Or maybe you could say 40 is the pass, so let's take every 20%. Let's take 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. And then I think a very different picture would emerge. Now, there is a way we can do these kind of histograms where we show this kind of diversity. And I'm going to show you what it looks like just because it's quite interesting to see how it shows you a totally different picture. So let's get rid of this normal curve I put over here. And what I'm going to do is just quickly whip up alongside another looking kind of graph thing. Okay, so what I'm going to do with this is I'm going to use a little bit of a different approach in that I'm going to say, wait, what did we go, 0 to 10, was it? Yeah. So I'm going to go 10, 20, 30, 40, 50, that's a 50, 60, 70, 80, 90, 100. So I won't win a prize for nice drawing. And then I'm going to go, that's 2, 4, 6, 8, 10, 12. Now what I'm going to do is I'm going to show this to you where I make the width of the bar as wide as what they're telling us. So 0 to 10, we had 4 people. 10 to 40, we had 8 people. So 40 is up in here. Oops, no prize for that. And then from 50 to 60, I had 12 people. Sorry, 40 to 50, I had 12 people. And then 50 to 60, another 8. And then for the rest of it, I had 4. Now you can see when I do that, although it's not a very beautiful graph, you can see that it's anything but normal. Anything but symmetric. You can look at how it's weighted almost too much this way. If you look at this like spread of marks we've had to put together to get my 4 people. Now back to the questions. So I've explained fully how it's done basically by taking uneven division of your answers or your selections. It's caused the skewness, it makes it look symmetric and it's not symmetric. Right, what is the true situation with respect to the spread of the marks in the class? Now remember, to do that, we can take the mean minus the median. Now you might say, how do we do that? Well, it's not too bad because if we look over here, we have 4 people here, 8 people here, 12 people here, 8 people here, and 4 people here. So we have 20, 28, 32, 36 people in total. So there are 36 people, which means the median would be the 18th person. And where would my 18th person be? My 18th person would be in this division here. So it's between 40 and 50, so we can say 45%. We can take the middle point. So I would happily say 45%. Right, to find the mean, all I would do is I would use the midpoints and the frequency to get myself out of trouble. So I would take 0 to 10 is 5 times 4 to halfway between this, it's 15 onto 10, so it is 25 times 8, added to halfway here is 45 times 12, added to the halfway mark here, which is 55 times 8, and then added to the halfway mark between 16 is 80 times 4. I'll bring up my calculator, and I would say 5 times 4 is 20, added to 25 times 8, which is 200. Okay, I'm being a bit lazy to input, I'd rather just work it out in my head, but that's fine. Added to 45 times 12, here I'm not going to stretch my brain. Added to 55 times 8, added to 80 times 4, which is 320. We get 1520. And of course we know that there are 36 people, so we divide by 36, and we get the answer 42.2. So our estimated mean is 42.2. So if we're using mean minus median, it's 42.2 minus 45, which is going to give me a negative answer of 3.8, I think. Doesn't really matter if I'm wrong there. It's smaller than 0, and therefore it's skewed negatively, or if you like, skewed to the left. Okay, and remember I talked to you about if we look at the actual thing, most of the data would lie that side. Yes, it does, and so that makes perfect sense. Right, so back we go here. So the true situation, mean minus mean is less than 0, therefore skewed negatively. Right, let's see what they say in the last question. If the pass mark is 40%, what percentage of the class did not achieve a pass mark for the term? Well, if we go over here, 40% is the cutoff point, so in actual fact we're talking about these pupils and those pupils. In other words, there would be 12 out of the 36 people that didn't pass. So we would do that, because that's how you get your percentage. 12 goes into there once and into there 3 times, giving me 100 over 3, which is 33.3%. So in other words, a third of the class did not pass. So the lady was making herself feel better when in actual fact she should have been feeling awful that her pupils had not done so well. So that brings us to the end of that question. And actually at this stage we are now finished with statistics. Hopefully you've really enjoyed it and you've got yourself clear on all the concepts. See you soon.